once again, you find yourself at the doorstep of the highest trending YouTube channel in the world. Everybody's talking about it. Everyone is talking about it. And as I walk around the classroom right now with nobody in it, the chairs are stacked, nobody's in here. It is literally just me walking around talking to nobody. I know that this video is going to result for me in social media fame, fortune, and glory. Oh, by the way, if you're watching this on Google Classroom, you better make sure you pull it up on YouTube and get me a view, okay? I'm tired of not getting views on my videos. So make sure you get me that view, okay? And now I'm starting to yell, and there's nobody in here. So maybe I should stop monologuing and get to this video so that I can go home. Okay, so here we go. How do we graph logarithmic functions? This is the material that you are getting from me via video. All right, so we're taking logarithm functions like we talked about yesterday, and we're looking at how we can graph them. All right, so first thing we got to talk about transformations of exponential and logs. Here's the deal. All the transformation rules are the same, as they always are. So all the rules from before, like with moving up and down, left and right, flipping, all that kind of stuff, all the rules are the same. It just looks a little bit different. Okay, so let's look at A. Let's look at A. F of x equals 2 raised to the x minus 3 power. Well, that is inside of the function, right? That's not on the end. That's on the inside. So remember, if you're on the inside, that's right and left, and it's the opposite of what you see. So if it's minus 3, that means we're going right 3. Also notice 2, that's the base of this thing. So it doesn't matter what the base number is. That's not doing like a stretch or a shrink or anything like that. That's just part of the function. All right, so there's only one transformation here. It's right 3. What about in B? We have 3 raised to the x power minus 7. Remember, if you're adding or subtracting something on the end, on the outside of the function, that's up and down. So this is down 7. Okay, so like I said, all the rules are the same. Let's look at a log. This one has a little bit more going on. There are 3 transformations here. One right here, one right here, and one right here. So the negative in front causes a reflection. Okay, it causes a reflection over the x-axis. All right, what else do we got? We have this 4 in front. So if you're multiplying a number in front of everything, remember that's a stretch or a shrink. If the number's a fraction, it's a shrink. If it's bigger than 1, it's a stretch. So this is a stretch of 4, and then we have one more transformation here. The plus 3 on the end takes me up 3. Okay, so hopefully now these rules are coming back to you. It's all the same rules. We're just dealing with different types of functions. So let's do one more. I have log base 3 of x minus 3. Okay, so I only have one transformation here. This is on the inside of the function, left and right, opposite of what I see. So a minus 3 takes me right 3. Okay, and again, notice how the base of the log, that's not a transformation. That's just part of the function. Same thing up here in C. The base of that log didn't do anything. It's just part of the log. Okay, so those aren't transformations. All right, so hopefully that makes a little bit of sense. All the transformation rules are the same as they always are. Now we're just dealing with exponentials and logs. Okay, so now let's actually do an example of when we graph something here. So it says graph the function y equals log base 2 of x plus 3. Well, first, before we graph it, let's think about the transformations. What do we have? There's 2 of them. Plus 3 on the inside, that means I'm going left 3. and then down 1 because of the -1 on the outside, right? So those are my two transformations, okay? So for our purposes, guys, we're just going to use Desmos to graph these things. There is a roundabout way of doing this by hand, but we are not going to do that. So instead, we're going to graph using Desmos and then just say some things about what the graph looks like. So I'm going to pull up the Desmos Desmos graphing calculator, and I'm going to graph this equation, okay? So here's how you're going to do that. You're going to type y equals log, just type it, log. Here's how you type the base 2. You're going to hit shift, and then you're going to hit like the hyphen button. It's right next to the 0 button, okay? So shift, and then the hyphen button, that's just to the right of the 0 button on your keyboard. That'll put you down into like little number mode. So then I can type a 2. What I need to do after that is just hit the arrow key to the right, and it gets me out of that. And then I can type the rest of this, x plus 3 minus 1, okay? So here's what the graph looks like. Here's what the graph looks like. I'm just going to pick 2 points. I'm going to pick 2 points to graph on my log. Try to pick some good ones here. I got 1, 1 right here. I have -1, 0, so 1, 1 and -1, 0. I can graph those things and then get a sketch of what this looks like. Notice how it's kind of like sort of like a parabola, but not really. It's just this big curve. So I got -1, 0, and I have 1, 1. So I'm going to graph that on the side here. -1, 0, and 1, 1. Okay. And the graph looks something like that. Okay, that's what we're dealing with. So now I got to tell you something about the graph of a logarithmic function. Question is this: what x value does it look like the graph never crosses? By x values, I mean parts on the x-axis. Well, if you look at this, it looks as if this thing might never, ever, ever cross at x equals 3. Or sorry, -3. X equals -3. And you might be thinking, well, I think it is going to cross. It's going to take a little while. This thing is actually never going to cross -3, okay? It's going to get really, really close to -3, but it's never going to cross it, all right? So this is something that we call an asymptote. Yes, you heard it correctly. The word is asymptote. An asymptote is a line that a graph approaches but never crosses. It can either be a horizontal asymptote or a vertical asymptote. When we're talking about a log function, it's always going to be a vertical asymptote, meaning a vertical line, like this line right there, right? It's never going to cross that, okay? To find the vertical asymptote of a log, all you need to do is set whatever is inside the parentheses equal to 0 and solve it. So let's go look at my equation. Look at the parentheses. It's x plus 3. So all I need to do is take x plus 3, set it equal to 0, and solve it. Well, that's pretty easy. It's -3. And just like it kind of passed the eyeball test, right? X equals -3 is this line right here. And we kind of saw that already, right? So x equals -3 is the vertical asymptote of this log graph. It will never cross that line, okay? But for our purposes, really all we want to be able to do is determine what the vertical asymptote is. And in order to do that, you take what's in the parentheses, you set it equal to 0, and you solve, okay? So let's do some quick examples of this. It says find the vertical asymptote of each log function. Remember, all I got to do, take what's in the parentheses, set it equal to 0, and solve it. So it's -4, right? That's pretty straightforward. Or what about this one? Number 2, x minus 5, set it equal to 0, solve it, and you get 5, okay? Maybe you can see how this is working. So all you got to do is put what's in the parentheses equal to 0, solve it, and you got it, okay? So that is for a log graph. Now let's talk about when we're dealing with an exponential graph. So now we were doing with logs before, now let's do exponentials. But before we do that, we're kind of right in the middle of this video. You're probably wondering, when is he going to give me the code word that I need to go say to him? Well, the code word is right now, okay? Here's what I'm going to tell you the code word is. The reason I'm doing it halfway through is so that if you just fast forward to the end, hoping to get the code word, you'll be disappointed. You got to actually watch the video to get the code phrase, all right? So here is the code phrase for a little bit of fruit snack action when I come back on Tuesday. You're going to come up to me. You're going to shake my hand once again, and you're going to say this, Mr. Smith, it's on like Donkey Kong wearing Sean John in Bhutan. Okay, one more time. This is it. Come up to me, shake my hand, and say the following, Mr. Smith, it's on like Donkey Kong wearing Sean John in Bhutan. And if you say that to me and shake my hand on Tuesday, I'll know that you watched the video, and I'll give you some fruit snacks, okay? But you're going to finish the video, even if you just heard that, because you're a good student, all right? You wouldn't dare just stop watching the video now that you've gotten the special code phrase. You're going to keep watching the video. So here we go. Let's graph this thing. First, let's think about the transformations. There's only one. It's going up 2. That's it. That's the only transformation, up 2, okay? So again, get my graph out here. Again, we're just going to use Desmos to do this. All right. So let me pull up Desmos real quick. Similar to the last problem, it's 3 to the x plus 2. Desmos, I'm going to clear that out. Y equals 3 raised to the x power. Remember, that's shift 6. Shift 6 will put you in exponent mode. Arrow once to the right, and then do plus 2. So 3x plus 2. Here's my graph. Okay, so let's get some points that I can use here. 0, 3. This looks like 1, 5. All right, 0, 3, and 1, 5. And notice how it kind of levels off here right around 2 on the y-axis. Okay, so 0, 3, 1, 5. Those are 2 points that I can use to graph this thing. 0, 3, and 1, 5. So let's go get this graph. We got 0, 3, and 1, 5. Okay, and it levels off sort of at 2. There's my graph, my exponential graph. All right, so again, we can have asymptotes with an exponential graph as well, except now it's going to be horizontal, meaning the line it never crosses is horizontal. It runs left to right. And you can kind of see that line is right here at y equals 2. At least that's what it looks like, right? That looks like the line that this thing is never, ever going to cross, okay? To find the horizontal asymptote on an exponential function, here's all you got to do. Just look at the number applying a vertical shift. What I mean is look at the number at the end. Look at the number that's moving you up and down, and that is your horizontal asymptote. So this one is y equals 2, which is what it looked like over here, right? So let's do a couple examples of this. It says find the horizontal asymptote of each exponential function. All you got to do is look at the last number. This one is -3. And I'm using y equals -3 because we're talking about a horizontal asymptote, right? So it's got to be a line running left to right, which has to be on the y-axis. Okay, so let's do some other ones. This one, pretty easy. It's 2. This one, pretty easy. It's -7. What about number 2? Well, there is no vertical shift, right? If there is no vertical, it still has an asymptote, and maybe you have a sense of what it is. It's just 0. There is nothing going on. There is no vertical shift. So the asymptote in this case is just y equals 0. Okay. All right. That is it for this video. Thank you for watching. I'll see you guys when I come back.